Chapter 1, Section 3 is about measuring and constructing angles. So at the end of this lesson, you should be able to name angles in various ways, to classify angles as acute, right, obtuse, and straight, to use a protractor to find the measure of an angle, to recite and use the angle addition postulate to find angle measures, to correctly use the term congruent and to use arc marks to identify congruent angles, and finally, to use angle bisectors to find angle measures. So let's talk about what an angle is at first. An angle is a figure formed by two rays with a common endpoint, and we call that endpoint a vertex. So remember, a ray was one of those terms that we built on. We took a point and a line and kind of put them together. So if I just have one ray out in space that connects with another ray that happen to have the same endpoint, I've just made an angle. And because this is a point, we name it with a capital letter. But to symbolize that this letter represents an angle, we use a symbol that kind of looks like an L. It has a flat bottom and then it points up. So that's angle R. Or we can also name it by other points on the ray. So if we look at this one down here, this first ray is RS, and then RT is another ray. So we can name it angle SRT. We go SRT, bump, bump, bump. We can also name it the other way around. We could start here at T and go TRS, and it's going to be exactly the same ray, or exactly the same angle. And then the other thing that we tend to do is on the inside of an angle, we tend to give it a number. So if there's more than one, we can quickly name it, this is angle number 1. I can name angles in various ways. Now, using a protractor. Protractors are kind of weird looking. They have angle measures on two sides. If you look here, this one starts at 0, works its way up to 90, which would be straight up and down, and then it comes back down to 180, which is a straight line. And then on the inside, it does the same exact thing. Now, depending on what side you start with, if you start over here, you're going to use the top. And then if you come over here and you start here, you're going to use the bottom numbers. Most of the time, we line up one of our rays with the bottom part here just to make it easy to measure how high we're going. If this starts at 0 and I got to go up here, I know that it's 50 degrees. So let's test one out. I want to know the measure of angle WXV. So I'm going to find W, connect to X, connect to V. So I want to know how big this is right here. So because I'm starting here, I'm going to work my way up at the bottom, and I see that it hits right here at 30 degrees. So that means that angle measure is exactly 30 degrees. Now the next one's a little trickier because it's kind of right in the middle. I want to measure ZXW right here. Now when I look at this, it's not lined up on this bottom. So I have to pick either the top or bottom measures and then subtract them to find out how much space is in between here. So let's pick the top ones. This crosses here at 50. And then this one over here on the top is at 150. So how many degrees are in between the 50 and 150? Well, there's exactly 100. And we could have used the bottom to do exactly the same thing. So this one right here is at 30 on the bottom, and then if I trace it here, it's at 130. So again, there's still 100 degrees in between there. We just have to be consistent on which we use, the top or the bottom. I can use a protractor to find the measure of an angle. Different types of angles. So now that we know how to measure them, we like to classify them. 90 degrees and 180 degrees tend to be where we go in order to classify. So if you're smaller than 90 degrees, but bigger than 0, we call you an acute angle. Cute little tiny angle. Exactly 90 degrees is kind of important. We call that a right angle. Chances are you're really familiar with that one. If you're in between 90 and 180, we call you an obtuse angle. And then if you're exactly 180 degrees, your straight angle. And remember, we already talked about these. These are opposite rays that go in exactly opposite directions. So you'll be given an angle and have to tell me if it's acute, right, obtuse, or straight. I can classify angles. So now the angle addition postulate is one of those things that makes a lot of sense, but again, we have to define it in geometry. So if S, just some point S, is on the inside of an angle, and in this case we have PQR, and then just some point S floating out in space. If I make two more angles here, angle PQS right here, and then angle SQR, those two right there, those added together, right here and right here, should total the whole angle. And we call this the angle addition postulate. So here goes the reciting part. You should be able to remember that. So now let's practice it. If I look at this angle, it has something cutting it in half. And this says the measure of angle DEG, so this whole thing right here, is 115 degrees. And the measure of angle DEF, one of the little ones, DEF right here, is 48 degrees. We need to know FEG. We're going to find this one right here. Now, we know that if we add DEF and FEG together, we're going to get DEG. So this says that we have the DEF plus FEG has to add up to DEG. So here's a little math problem. We know DEF is 48 degrees. We're trying to find FEG, and we know that the total is 115. Hopefully you were already subtracting those two things in your head, and you would end up with 67 degrees. And then double check that. Does 48 plus 67 give you 115? And in fact it does. So I can recite and use the angle addition postulate to find angle measures. Now, congruent and equivalent angles. Remember, congruent is when the measure is equal. We don't like using just a straight up equal sign. We like something special for geometry. So we use the equal sign with the squiggly over it. There's two ways to show that. Most of the time, we're going to use something called arc marks. Remember with segments, when we drew them out, if we wanted to show that two segments were exactly equal, we would place tick marks on them. Arc marks are exactly the same thing, but just for angles. So most of the time we do one little swooshy. Or, if we're representing multiples, we can have two little swooshies, and all the ones with two mean that they're equal. Another thing your textbook likes to do is color coordinate. So, like green angles are exactly the same measure. Where back here we had like a blue and a red one showing that they were different angle measures. So if they are the same color, then they are equal, but a lot of times we work with pencil, so arc marks are the best bet. So I can correctly use the term congruent and use arc marks to identify congruent angles. Last thing we got to talk about, something called an angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. So if we have some angle out in space, let's say LJM. So there's some point L, J is right in the middle, and then some point M here. If we have an angle JK, so just some K out here, colors aren't working, just some K out here, and an angle through it. And if we say that it bisects this angle, then we have made two angles right here that are congruent. LJK has to be equal to KJM. So when you say something bisects, that means that you get two angles that are exactly the same size. It's kind of like finding the midpoint, but in angle format. I can use angle bisectors to find angle measures. So let's prove it. Here's an example. Ray KM bisects angle JKL. The measure of angle JKM is 4x plus 6 degrees, and the measure of angle MKL is 7x minus 12 degrees. We need to find the measure of angle JKM. So a lot going on here. Draw yourself a picture. We have this angle right here, JKL. This is a ray that goes on forever. These are points here. And if KM bisects that, remember that means it cuts it into two equal pieces. So this is equal to this. The measure of JKM is 4x plus 6, and the measure of MKL is 7x minus 12. We need to find this whole thing, JKM. So the first thing we know is that these angles are congruent. They're exactly the same. So that means we can set 4x plus 6 equal to 7x minus 12. And now this turns into an algebra problem, everyone's favorite. Let's solve for x. I'm going to subtract 4x from both sides. So I end up with just 6 over here equals 3x minus 12. Get all my numbers on one side now. So I have 18 equals 3x. So that means x has to be 6. Not done yet. All that tells us is the missing value for x. We got to plug it back in here to find out what those angle measures are. So I'm going to plug in 4 times 6 plus 6. And when we do that, we end up with 24 plus 6, or 30. And we can double check this, but remember, these angles are equal, so it should give us exactly the same thing. If I do 7 times 6 minus 12, that's 42 minus 12 more, which is 30. So now remember, 30 wasn't our answer either. We're looking for the measure of this whole angle right here. And because that cuts it in half and each of these are 30, we know the measure of angle JKM has to be 60 degrees. I can use angle bisectors to find angle measures. So, can you name angles in various ways? Classify angles as acute, right, obtuse, and straight. Can you use a protractor to find the measure of an angle? Can you recite and use the angle addition postulate to find angle measures? Can you correctly use the term congruent and use arc marks to identify congruent angles? And can you use angle bisectors to find angle measures? If you can, you are doing awesome in section 3.